Okay, in this particular lesson, we are going to be talking about two different things. We're going to be talking about the scientific method and experimental design. Both of these are processes that scientists use when they are performing investigations or experiments. So they are going to be processes that they use in order to walk through the proper steps to get proper results or valid results. So first one that we're going to talk about is the scientific method. So what I want you to do is I want you to imagine that you're a scientist. And what you think is that you actually believe you just discovered this new weight loss drug, this great new weight loss drug that possibly may be a miracle, all right? You think that you've discovered it's an herb, all right, which an herbal weight loss drug would be even better because, you know, people would have that idea that being all natural, coming from the earth, an herb that provides weight loss. So you want to find out whether or not this is really actually your discovery, whether this is going to be your big ticket to fame in the scientific community, and if you're really the one that's discovering it, or someone's already found this weight loss herb and already begun investigations into it. So how are you going to do this? How are you going to figure out if somebody else has already discovered it? How are you going to go through a process of performing an experiment to make sure that it really is a weight loss drug? And how are you going to set that experiment up so that the results that you get can actually be trusted? Right? This is all part of the scientific method, this whole process that scientists are going to use, right, when they investigate, right, investigating new knowledge or already existing knowledge. So this is really kind of a part of performing lab experiments for us. This is how we're going to solve problems, which is really what experiments do. You're presented with a problem and the experiment is supposed to come up with answers to the problem. So this is how that experiment is prepared for in the scientific method. All right, so there are 7 steps. A lot of times I use a mnemonic device for my 7 steps. The mnemonic device that I use, Orphec on a red plain, hippies eat cheese. I realize that this makes absolutely no sense, but mnemonic devices often don't, and it seems to work relatively well. So on a red plain, hippies eat cheese. So our first step in the scientific method is to observe. So in this case, the observation that you would have made is that you found a new herb. You discovered this new herb. Your observation was, wow, a new herb, all right? Which would move you on to your second of that mnemonic device, the second step, which would be to ask a question. There's that A. So based on your observation, the question that you're going to ask is, maybe this particular new herb that you think you discovered could help people lose weight. All right? So you ask yourself a question. That question is really what's going to drive the experiment for you. So any good experiment needs research to start off with. So the R in Orphec, to research, you need to research, has somebody already discovered your herb? Has somebody already performed experiments about your herb? Maybe somebody found your herb, but they performed a totally different experiment on it. So you search online, medical journals, right? And you don't find anything about this new herb that you think you've discovered. So you found out, however, that it's called Saffrodilly. No, this is not real. I'm making this up, guys. So you start to plan, right? You start to plan accordingly for an experiment that's going to answer that question. Remember, the question was whether or not Saffrodilly could perhaps contribute to weight loss. So you start to plan out this experiment, and this is where experimental design is going to come into play. So during the planning stage of the scientific method is where experimental design is going to have its part. So you start to design this experiment in order to figure out whether or not Saffrodilly can contribute to weight loss. So you get people, and you divide them up into 2 groups, and one of the groups is going to take your herb, etc., etc. After you've designed this whole elaborate experiment, you need to make an educated guess. Why do you think that that guess is educated? Why would I call it an educated guess and not just a guess? Key thing to recognize is that in the scientific method, you already researched. A good scientist would have already researched and already be well educated on this information. So you create this hypothesis, this educated guess for what you think the outcome will be. So obviously in this case, your expected outcome is that Saffrodili will help people lose weight. So then you perform the experiment, right? This is when you're actually going to collect your data, your observations, and you're actually going to test your subjects. And finally, you're going to conclude. You're going to wrap it up, explain what your results were, whether or not your hypothesis was correct, if you made any errors. So I gave you an example of a conclusion here that after 8 weeks, 12 out of the 20 people in the Saffrodili group have lost weight. However, 8 of the 20 people in the other group lost weight too. After testing, the hypothesis was incorrect. Perhaps exercise plans should be the same for all the test subjects. This experiment should be revised and performed again. So, figuring that comparing the 12 versus the 8 for weight loss wasn't really a substantial difference. So maybe there were some errors. Maybe one of the groups had people that were exercising more frequently than others in the group, and kind of skewed the results. Which leads us to the idea of experimental design and why experimental design is necessary for us, all right, so that you don't have those skewed results. Again, there's that mnemonic device on a red plane, hippies eat cheese. If this one doesn't work for you, obviously you can come up with something of your own if that works. So, like I said, leading on to experimental design. We need to get back to that weight loss herb and focus on that. Using a good example always helps to understand scientific method and experimental design. When you plan it, you need to be detailed and organized. I think the biggest thing to focus on is the organization that's involved in experimental design. You need to make sure that you've kind of covered all of your bases and thought of anywhere that mistakes could possibly happen or that results could slightly be altered, right? Make sure that your results aren't just based on chance. So, like I said, it occurs in the planning phase of the scientific method, and it's going to help improve our validity, all right? So, the things that it should always have: separate groups of test subjects, an independent variable, and a dependent variable. All right, we're going to talk about those a bit more in depth. So, when you separate your test subjects, right, you need to get 2 groups, and you need to split them. They need to be as similar as possible. Same ages, same genders, same weight, etc. And then you split them in half. A control group and a variable group, or an experimental group. So, for example, we have the control group versus the variable group in our case of Saffrodili, all right? The control group is going to be a group that's isolated, it's kept the same, you're not changing anything about that particular group, all right? And it's going to be a basis for comparison. Versus the variable group or experimental group, that's the one you're going to actually be experimenting on. So our example in our Saffrodili experiment is that we divide into 2 separate groups. All right, we divide into group 1, our control group, which consists of 20 people, 10 male, 10 female, ages 18 to 24. Group 2, which would be our experimental group or our variable group, is going to be 20 people as well, 10 male, 10 female, ages 18 to 24. It'd be even better if you could make, for every 18-year-old male in group 1, there's an 18-year-old male in group 2. You want to keep them as similar as possible. All right, identical twins are often used in experimental design. Right, they're easy to use because of their similarities. So our group 1 is left alone. We don't give them anything. We don't do anything to them. We're not expecting weight loss from group 1. Right? So group 1 would be our no weight loss. because we're not experimenting on them. We're not trying to get them to lose weight. Group 2, though, is getting the Safrodili. So this is the one we expect weight to decrease for them because we're experimenting on them, right? Then we have those variables that I mentioned. An independent variable, specifically we refer to it as what you changed, right? In a good experiment, you only change one thing. Multiple independent variables makes it very, very difficult to get valid results. So you typically change one thing when you compare your two groups. Dependent variable is going to change because of the independent variable. So it depends on what you change. So let's talk about looking at our two groups. We had group 1 versus group 2. Group 1 was 18 to 24. Group 2 was 18 to 24. Group 1 was 10 male. Group 2 was 10 male. Group 1 was 10 female. Group 2 was 10 female. Everything was exactly the same, except group 2 got Safrodili. That's what you change, all right? Taking Safrodili is the independent variable. Now, because we changed that one thing, we expect something else to occur. So after time passes, and we have all this time go by for both of our groups, we expect group 1 to have the same weight and group 2 to have a decreased weight. So our dependent variable would be weight loss, right? That's what you're collecting observations and data on in the end. So, like I said, the example, in the case of the Safrodili experiment, you got two groups. They're exactly the same except for that one little difference, the Safrodili erg, which would be your independent variable. And then you have a dependent variable. It even helps if you notice right here that we specify that measurements are going to be taken each Friday for 8 weeks. I mean, time frame. The more detailed an experiment is laid out, the more foolproof it is, the better chances that your results will be valid. So typically, all right, there's an if-then statement for remembering experimental design. We say that if the independent variable, then the dependent variable. So if Safrodili erg is taken, remember I said the independent variable was taking the Safrodili erg, then weight loss will occur. And I said that weight loss was our dependent variable. So an if-then statement. This pretty much wraps it up for our lesson on scientific method and experimental design. We'll go over it a bit more in class. If you have any questions, please feel free to see me.